Hi guys, happy Friday. Coach Collins is going to be here with you guys today. First thing I want to do is go through the lesson with you. We're going to take some notes. It should take about 15-20 minutes or so to take some notes, a little bit of practice, and then you guys are going to finish up with some independent practice, 12-4. If you're not able to complete the independent practice in class with Coach Collins, you guys will complete it for homework tonight and have it on Monday. Remember, Tuesday will be the district level assessment, the DLAs, which is going to cover everything from the beginning of the year up till today. All right, we're going to quickly go over how to do algebraic representations and transformations. So last week and then earlier this week we did translations, reflections, and rotations. So what I'm going to do is show you how to do it algebraically. It's real simple. We just got to follow a couple of steps, some easy rules. So I'll show you the rule, and then I'll have you do a practice example, and Mr. Collins will help you guys with that. All right. We're going to begin with some vocabulary. I just want to make sure we understand the word vertices. So if you guys would just take a second, go ahead and copy this down in your notebook. Mr. Collins, if you can pause the video here. All right, great. Welcome back. So a vertex is a point that describes corners or intersections of geometric shapes. So if we're looking at, per se, a triangle, it has three vertices, three intersections of this geometric shape, here, here, and here. And those will usually have points on a coordinate grid. So you'll have vertex A, vertex B, and vertex C, and each one has a place on the coordinate grid or assigned a place on the coordinate grid. So each vertex is associated with a specific coordinate on the grid. When we transform an image, we're changing the coordinates of the vertices. Again, Mr. Collins, if you pause this to make sure they get this in their notes for me. So let's say 3, -4. Let's say that's point A. So the coordinates for point A is x is 3 and y is -4. And you can translate that, rotate it, or flip it. And we'll talk about, flip, reflect it. So Mr. Collins, we're going to pause here, Mr. Collins, so that they can get this in their notebook. This is algebraic representations and translations. It's going to go in your notes section. So make sure you have the title and then draw the table or the chart. Welcome back. So you got that done? So when we move right a unit, we're going to add the value of the translation, or what we call a, to the x coordinate. So if we're going right 3 units, we would add 3 to x, right? Because we're going right on the number line. The origin is 0. We're moving to the right, so we're adding to the x value. So we have x plus a, y doesn't change when we go right. When we go left, opposite, we're subtracting value. We're moving left or negative down from the origin, so we're subtracting values from that. When we go up or down, we're moving along the y-axis, right? We're going up from the origin or down. Up is positive, down is negative. So if we go up, we're adding to y. When we go down, we're subtracting from y. So a quick example here. If we're going right 4, up 3, we add 4 to x because we're going to go right, and we add 3 to y because we're going up. So algebraically, it would look like this. The x and y coordinate would become x plus 4, comma, y plus 3. So if we had 3, -4, we're adding 4 to 3. So this becomes 7, and we're adding 3 to -4. This becomes -1. So when we translate 4 to the right and up 3, we go from 3 -4 to 7 -1. Next, I'm going to have you guys do a little bit of practice. So you're going to draw the table. I'm going to give you the rule, and then we're going to pause the video so that you can have time to complete the rest of the table. And then Mr. Collins will go over the answers with you. So let's go ahead and in your notebook, let's title it Apply the Rules to Find the Vertices. We're going to be translating, you write this down, we're translating right 3 and down 1. Okay. So we're translating right 3 and down 1, so you see we're adding 3 to x and subtracting 1 from y. Why don't you guys go ahead and pause here so that you can draw the table and complete the table. All right, great. Welcome back. So now that you have an opportunity to go ahead and apply the rules and find the new vertices, let's see how accurate you were. So when we add 3 to x and we subtract 1 from y, our new value, our new vertex, we have x is 3, y is negative 1. For y, we add 3 to 2, subtract 1 from 3, and our new vertex is 5, 2. And for z, we add 3 to 4 and subtract 1 from negative 1. Our new vertex is 7, negative 2. So translation is pretty simple. We're adding or subtracting to the x and y value, depending on whether or not we're translating right, left, up, and down. We're just adding or subtracting that value to each of the x and y values for all of the vertices of the object or the shape. Let's take a look now at representations of reflection. So again, I'll just pause here for a sec, pause the video so that you guys can copy this down in your notes. Make sure you get the table and write down the rules for the notes. All right, great. Now that you got that done, let's quickly just talk about it. When we're reflecting, all we're doing is we're flipping across the x or we're flipping across the y-axis. When we cross the x-axis, the x values don't change. The y values change. So what we would do is we're going to multiply each of the y values in the coordinates of all 4 of the vertices, or 3 or 5, times negative 1. So xy becomes x, y times negative 1. When we do it across the y, all the y values are staying the same, but the x values are changing. So same thing, we're going to multiply negative 1 times each of the x coordinates. So xy becomes x times negative 1 and y. All right, real simple. Let's go ahead and look at a table and give you guys an opportunity to complete a table. So here we're going to apply the rule to the vertices. We're going to imagine we're going to reflect across the y-axis. So remember, when we're reflecting across the y-axis, we're going to multiply each of the x coordinates by negative 1. So that's going to be our rule here. Rule x times negative 1 y. So if you guys go ahead and copy this table down in your notes, and then pause the video so that you guys have an opportunity to complete the table. Alright, now that you have an opportunity to do that, let's quickly go over the answers. So when we multiply x times negative 1 and y, negative 4 is x, so we multiply that times negative 1. And y does not change, so our new value, our new vertex becomes 4, negative 1. For s, follow the same rule, our new vertex is 1, negative 1. T, our new vertex becomes 1, negative 3. And u, our new vertex becomes 4, negative 3. So you see, for each of the 4 vertices, we apply the exact same rule. The rule that we apply depends on what we're doing. So here we're reflecting across the y, so the rule is to multiply x times negative 1, and y does not change. Let's do one more rotations. So we're going to look at representing algebraic representations of rotations. So first we have the rules. We have 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees. Let me give you guys a minute to go ahead and copy that down. So pause the video real quick. Alright. So when we do 90 degrees, what we do is we're going to multiply each of the x coordinates times negative 1, and then we switch the x and the y coordinates. So xy becomes y, negative x. Counterclockwise, we multiply the y times negative 1 and then switch to x and y. So xy becomes negative yx. For 180, we're going to multiply both of the coordinates by negative 1. So xy becomes negative x, negative y. We're not flipping the order when we do 180. All right, so we're keeping them in the same order. All right. So last thing we're doing here, guys, is I want you to go ahead and draw the table, and then let's pause the video so that you guys have an opportunity to practice and complete the rest of the table. All right. Awesome. Now that we've done that, let's go ahead and complete our fill in the table. So we have vertices of A, B, C. So let's see what we're doing here. We're going 90 degrees clockwise rotation. I hope you guys realize that before you filled out the table. So I want to follow the rule is switching the y and multiplying the x times negative 1 and then switching the y and the x. So it becomes y negative x. So for A, it's going to become 2 and then negative 4 times negative 1. And my new vertex is 2, 4. So you see we've switched. Y becomes x, and x, the value switches. So a negative becomes a positive becomes a negative. So we have 2, 4. For B, we have 4, negative 3 times negative 1. becomes 4-3. And C, 2-3 becomes 3-2. All you're going to do is follow those simple rules, guys. If you took your notes, you have all the rules right in your notebook, so as you come across your problem, all you need to do is go back and check in your notes what rule applies here, and then apply that rule for each of the vertices in your independent practice. So again, you guys are going to complete independent practice 12.4. If and when you finish today, go ahead and give it to Mr. Collins. If you are not able to finish today, you're going to finish it up over the weekend and turn it into Mr. Collins on Monday. And when I get back on Wednesday, I'll take a look at them, go ahead and apply them into your grade book. Good luck on your DLAs. Make sure you watch the Super Bowl, and hopefully you guys are all rooting for the Patriots. Remember, guys, whatever you do today, do your job. You know exactly what your expectation is. You know what you need to do. Do your job. Worry about you and nobody else. Have a great day.